I can imagine a whole new industry rising up to fill this market gap. On the one hand, countries tend to mourn about import dependencies of lithium, cobalt, and other raw materials, and then on the other hand, they just threw them to trash. I welcome you to this exciting episode of Let's Talk About Electric Vehicles. In succession of what we previously have learned about the battery production, today is all about the periods after usage, hence disposal, second use, and recycling of electric vehicle batteries. And now that we know that the lifetime of an electric vehicle battery is limited, such that it has to be replaced at least once throughout the vehicle usage, if not more often, it is time to address the consequences of the massive lithium-ion battery waste that comes along with electric vehicles. In general, with the growing demand for batteries, by the way, not only for electric cars, but for all sorts of electronic devices, the global battery waste has subsequently climbed up to an enormous amount. An Australian consultancy says that the waste is even increasing by 20% per year. An organization called Li-Cycle Corporation forecasts that in the time between 2017 and 2030, more than 11 tons of lithium-ion batteries will reach their end of lifetime. I must admit that living in a first world country, the electronic waste oftentimes seems to unobtrusively disappear. But of course, it does not just magically vanish. Most of the current battery waste is either dumped in landfills or incinerated. It is estimated that only about 2 to 5% of the disposed lithium-ion batteries are being recycled. What a low number! This practice does not only have tremendous consequences for the environment and, of course, consequences on the health of the poor people living close to toxic landfills or poor people who work in that sector, but moreover, the way in which lithium-ion battery waste is handled right now is also from an economic and power strategical perspective absolutely ridiculous. I will explain to you what I mean by that in a second, but let me give you a little outline of this episode first. I will start by probably the most devastating part, which is the consequences of the current practices, before I continue on analyzing the potential for improvement, because yes, there is an enormous potential for enhancement on so many dimensions. Moreover, I want to actually introduce you to some technical details about the recycling methods as well, but no worries. It won't be too complicated. In fact, as I myself don't have a chemical science background either, it will honestly just be a summary of the feasible mechanisms. But still, I find it very important to break down the abstract imagination of battery recycling to a few very simple concepts. And finally, the episode will finish up by pointing at the biggest challenges and the next steps to take. The majority of disposed lithium-ion batteries ends up in landfills. And by majority, I mean a number that is between 90 to 100%, actually very close to 100%. While lithium seems to be sort of a lesser evil as its toxicity to human and the environment is quite low, when it contains other toxic metals and when it is disposed in large quantities, it can turn into an environmental hazard. Certain parts of the battery, such as the electrolyte, are toxic and inflammable. And furthermore, the remaining charge in the battery is dangerous for all of the people that work in that recycling sector. It could cause fire and explosion and so on. The lack of profound recycling methods means not only a burden for the environment though, but it's also a massive economic loss due to the potential recoverable value. The Global E-Waste Monitor report estimates a value of 55 million euros worth of materials wasted in the year of 2016. Valuable materials that could have been recycled and could have re-entered the market, but were instead just dumped on a landfill where they obviously do no good to anyone. Even the transportation of the waste is an unnecessary effort and costs time, money, energy, and emissions. On the one hand, countries tend to mourn about import dependencies of lithium, cobalt, and other raw materials, and then on the other hand, they just threw them to trash. Therefore, the current practices make us strategically weak and dependent. Before we go right away to recycling, let me point out the potential for second use, because only because the battery is not appropriate for a vehicle anymore does not mean that it is now completely useless. In fact, for electric vehicles, it's common to sort out a battery when it has decreased its energy storage capacity down to 80%. Therefore, it's very likely to still be accurate for a different type of usage. You just have to adjust the battery management system, and voila, you could, for example, use it as energy storage for solar systems. But if the battery really gets old and its storage capacity is so low that there's no reasonable use for it anymore at all, recycling is the next option. The question that probably everyone now is waiting for, especially after we talked so much about mining, or rather exploiting, natural resources in the last episode: is it technically possible to gain back all of the raw materials of a lithium-ion battery? In a research-based information sheet of the German Association for Mechanical and Systems Engineering, VDMA, I find that at least 50% of the materials of an average battery can be recycled, whereas the Australian consultancy CSIRO goes even further and says that 95% can be recycled. By comparison, other battery types such as the lead-acid batteries show already recycling rates of 98%. So it's just a lithium-ion battery that is not yet recyclable. Although the lithium-ion battery was actually introduced already about 20 years ago, there is no sustainable recycling routine yet. Recently, there have been lots of achievements in the research of recycling methods though, but unfortunately most of them are still pilot projects and limited to laboratory scale. The lack of profound recycling methods is probably the reason why only an extremely small share of the current battery waste is recycled, as I said before, only around 2 to 5%. Recall that the lithium-ion batteries are not only found in electric cars, but also in smartphones and laptops. Therefore, now completely unrelated to the electric vehicles, by further developing the battery recycling process, we could also finally learn how to deal with old batteries from smartphones. But how does the battery recycling work? Let's have a short break here to relax our brains before we get into the technical aspects of recycling. Welcome back to Let's Talk About Electric Vehicles, episode 3, where we talk about the increasing battery disposal that comes along with rising popularity of electric cars. So far, we've learned that currently almost all of the lithium-ion battery waste is dumped in landfills, which is not only bad for the environment, but also from an economic point of view, a complete nonsense, since we're basically disposing valuable materials. And now I will discuss what it means to gain back these valuable materials from electronic trash, hence what the prospects of recycling really are. First of all, let's recall what a battery consists of. A typical lithium-ion battery consists of metals such as lithium, cobalt, copper, aluminum, iron, nickel, and furthermore, organic chemicals and plastics. Some of the metals, such as copper, aluminum, and iron, can most probably be fully recovered in their elemental state, whereas others like cobalt, lithium, and nickel can only be recovered in a chemically combined state. The raw materials with the highest recycling potential are cobalt, nickel, copper, and aluminum. The recycling of batteries happens in different stages, and it all starts with the collection process of used batteries. The more precise this sorting of the battery chemistry, the more specific can the recycling method be, and therefore the more efficient can the recycling method be. It requires, therefore, a large upfront investment in proper sorting machines. In the next step, all of the batteries have to be fully discharged, and to achieve this, you could, for example, place them in a salt solution. And then you start by mechanically taking apart the case, the plastic, and all other parts that can be dismantled, for example, through crushing and scraping. And after the battery is mechanically disassembled as far as possible, there are several different approaches to continue, including pyrometallurgy, hydrometallurgy, and biotreatment. And actually, to gain back the most from a used battery, it's probably best to employ a combination of different approaches. Methods like acid leaching, hence the use of certain organic and inorganic acids that cause a chemical reaction and precipitation, are already commonly used for battery recycling. I also read about using a chemical compound called NMP, which is sort of a yellow liquid. Another possible procedure is to use ultrasonic washing, especially in combination with agitation. Also commonly used are various thermal treatments, hence either placing the electric disposal in a furnace or cooling it down. The currently widely used smelting procedures recover about 30 to 40% of the constituent materials, while the rest of the battery is still mostly volatilized, cleaned, and emitted to the atmosphere or ends up in solid waste, so also called slag. What I find very interesting is another method that, aside from acids and chemical compounds that cause beneficial reactions to extract the materials, some organic microorganisms, hence bacteria and fungi, lead to similar results apparently. Aciditobacillus, oh god, I hope I pronounced this the right way, ferrooxidans is the name, for example, for one of these bacteria that can dissolve valuable metals from electronic waste. Now that we know about the recycling prospects for batteries, it is time to draw some conclusions. The foundation for sustainable battery disposal is the establishment of an efficient collection and sorting process. It needs a structured guideline for the right disposal, not only for consumers, but especially for industries. Furthermore, large investments in good sorting machines and or good sorting mechanisms have to be made. The problem goes far beyond just a simple lack of consumer awareness. The electric waste sector is actually a massive sleeping industry, a market gap with unexploited potential, since it would be very profitable to regenerate the materials of old lithium-ion batteries and reintroduce them to the market. It is expensive and senseless to dump the precious materials in landfills. I can imagine a whole new industry rising up to fill this market gap, maybe starting by some little projects where the waste of one company can be used by another company or something like that. Equally important as proper sorting methods is the enhancement of battery recycling research. As we've learned today, there are so many different ways to recover valuable metals. We need sophisticated large-scale procedures to recover as much material as possible, with preferably minimum energy consumption and minimum safety risk. As soon as the recycling of batteries is more advanced, we can definitely expect further price reductions in the battery production as well, which means further price reductions for electric cars. Yay! Okay guys, that is it for today's episode. Please let me know what you think, and feel free to send me any further reading material. My contact information as well as all of my sources are in the show notes. As for the next episodes, I plan on talking about infrastructure challenges, consumer preferences, government regulations, and many other topics that are related to electric vehicles. I'm looking forward to talking to you again soon. Have a great day and bye!